This is the 𝐥𝐴68SC11 model. Basically, it is divided in three parts. One is display, motherboard, and CPU side. On display, we have two options: 16:1, 16:2, or 20:4. This is the 20:4 display. On motherboard section, we have to provide 8255 ports. Here we have provided two 8255 ports. This is the lower 8255 ports, and this one is the upper 8255 ports. These are the two 26-pin FRC connectors. The respective 8255 ports pin come on this 26-pin FRC. This is for lower port and this is for upper port. So by using this upper and lower port, you can interface stepper motor, DC motor, traffic light controller, scan technique, ADDA temperature, then ADC DAC, elevator, etc. This is 8253 timer counter IC. This one is the 8251 synchronous IC. This is the MAX 232 and D-type 9 connector for the PC communications. Here we have provided 89C2051 IC, which is mainly used for keyboard and display interfacing IC. The 74LS373 is a latch IC is provided here. The clock divider IC, PAL IC is provided here. NAND gate 7400 break IC. This is the 6264 8KB scratch pad memory IC. Here we have provided on board 20 MHz, which is divided the clocks by using these clock ICs. The 74LS24 ICs here. All these ICs are buffer IC, address buffer and data buffers. 62256 32KB. It is a battery backup memory. This socket is for expandable memory IC, and this is the battery, rechargeable battery to provide for 62256. This is the 50-pin FRC socket, which is useful for it comes here the interrupt and address and data pins. This is the reset button, and this is for the single stepping and interrupt control ICs push button. On the bottom side, we have to protect to our microcontroller, and for this is the bottom acrylic to see the microcontroller and EEPROM and their respective ICs. This is main 68SC11 8-bit microcontroller with 16-bit address bus. It is operate on 2.5 MHz frequency. Here two GAL IC is provided. One is the memory decoder logic and second is input output decoder logics. In between that there is a EEPROM IC 27C512, which is holding the monitor programs, and 74LS373 it is a latch ICs, 74LS00 NAND gate and 74LS32 OR gate, which is provided on CPU card. This is the 26-pin socket is provided on CPU card. The information about the 26-pin socket, the pin information is given on the student workbook manual chapter number 9. So if you using this 26-pin FRC socket, please refer manual on chapter number 9. This side we have using the analog linear port for the ADC controller, analog to digital controller. For the 68SC11 inbuilt ADC. So on the back side of this mold, we have given the provide the connection of for the power supply, and second is the PC keyboard 101. With this kit, we have provided to you one power supply, which is two wires, one for the Casio connector which goes to our kit, and second is the 4-pin realignment socket, which is used for application board like stepper motor, DC motor. It provides the plus and minus 12 volt power supply, which is required for the application port. So only this 5 volt connector is used for this kit. This is the procedure how to connect the power supplies. Okay, when you connect the power supply, then connect PC keyboard. After connecting the PC and power supply, switch on the power supply, open the mode. When you open the switch on the power supply, it shows you Anshuman on display. Okay, so after that we are using the how to operate the kit by using the manual. So we have to provide the procedure how to use the 68SC11 kit and how to write the program in assembly language as well as opcode, how to see the disassemblers, and how to operate the single stepping. All these are the procedure is provided in manual. So with this kit we have provided to you two manuals. One is student workbook and second is instruction guide. So follow the student workbook to operate the operation of the 68SC11. In student workbook, refer the chapter number 2. Here we have to provide how to write the program in opcode. One addition program is given in this manual, addition of two 8-bit numbers. So when you have to press on kit keyboard, press S, it shows you substitute, and when you press enter it shows you external memory, and respect to their description is also provided in manual. So by using this manual we see the operation of opcode method. Press S on keyboard, it shows to you substitute. Press enter, it shows external memory address. Here we have to give the memory address or starting address of program. We recommended to you write down your program in battery backup memory locations. Battery backup memory location is start from 4000 to 7FFM. If you want to see the memory address locations, you refer the chapter number 9. There we have to provide the memory address location table. Okay, so first we have to write down here the program in 5000 locations or any location from starting 4000 to 7FFM. So I write down the program in 7000 locations. It shows to you by default any garbage values. So here we have to give our opcode 86. Then my data is 22, first data C6, and my second data is 33. So in this program I add with 22 with 33. 1B. After complete the program, or if any mistake is there in opcode in previous location, how to go? You have to press Ctrl U. By pressing the Ctrl U, you see the previous locations, or you go to the previous location and make the corrections. Okay. After complete the program, press escape. All this procedure we have followed by manual. Press escape. It shows to command mode. Then now we want to execute the program. For execution procedure, press G. It means go to, enter first, enter address. Here we have to give the address of the program. It is 7000. Enter, done. Now we want to check the register or content of the registers. So our result is stored in accumulator. So we want to check the accumulator registers. Press S, enter, then any key, escape, enter, or escape key. It shows registers, enter, it shows name, and one by one register content it shows to you. Here we have our program result is stored in accumulator. It shows to you 55, means 32 plus 22 is 55. See, this is the procedure of opcode. Okay. Now we want to write down the program in assembly language. So how to write down the assembly language? This procedure is provided in chapter number 13, expand mode. So in student workbook, refer the chapter number 13. So as per chapter number 13, we see the procedure on kit. Press E, expand mode, enter, then press A. If you press here enter, directly it goes or restart from 4000. If you want some another location, you give the another location first and then press enter key. Okay, here I have pressed directly enter key. It shows start from 4000. Now I want to write down my program in assembly language. Give the instructions LDAA space shift hash. Here we also use the backspace. Now give the data. My data is 55. Enter. If there any instruction is wrong, it shows to you mnemonics bad or bad command. So it always shows to you error. Then second instruction is LDAB. I stored my data in B register. It is 55 again. Then I want to add with accumulator to B registers ABA. Enter. And the last location is RTS. Return to the command mode. Press escape. When you have finished the program, press escape. Then you have to press the Q and press enter. It comes out in the command mode. Now the execution procedure is same. Press G, enter, enter 4000 starting location. Wait, done. Now I want to check the content of the register. Same procedure. Press S, enter any key, enter or escape, enter, name, register. Now my result is AA, means I add with 5pi with 5pi, it shows me A in hex. This is the procedure of assembly language, how to write down in the assembly language. Now I want to check the program in single stepping. So for the single stepping, you first write down the program, and then when you execute the program, you see the step by step execution. For the single stepping, press G, enter, then any key. It shows single stepping. Press enter, start address. If I press here 4000, and after 4000 press F10 so that you can see single stepping by step by step. Otherwise it shows to you directly. This is the procedure of single stepping. The next procedure is disassembler. For the disassembler, you refer the chapter number 13, expansion mode. Here we have to give the assembly language as well as disassembler procedures. For the disassembler, press E, enter, then U, and if you press enter key, it shows to you 4000 location starting. So if you press enter, it shows all the location address with mnemonics. Okay, this is the procedure of disassembler. For to come out from the disassembler, press escape, then Q. It return to the command mode. Okay, then